Okay, so we'll be looking at fractions today. This is one of the basic aspects of mathematics that you need to understand before solving other areas of mathematics. Uh, we're going to be looking at some examples, complex examples of fractions. But before that, let's look at some basic points that you need to understand in order to solve some serious equations of on fractions. So one of those points is whenever you see something like a mixed fraction, maybe solving through multiple fractions, please, it's important to change to improper fraction to make it simpler for you to solve. Another important thing is when you are adding or subtracting between fractions, please apply LCM. Very important point you need to remember. Then also, this point, subtracting mean multiplication of fractions. So like sometimes you have fractions you have to multiply through when you do not have what to cancel out. But in this situation, you have something to cancel out, so you just do that immediately. But if you do not have anything to cancel out, just multiply through, and you get your answer. Please note that off is also the same thing as multiplication, so you can just change it to times. Another important point is dividing between fractions. So you can have the division sign between two fractions. It's important to note that what happens with that division sign is this: that when you have a division sign there, it quickly changes to a multiplication sign for you to be able to complete the fraction. And when you change the sign to multiplication, you invert the right hand side. So like you invert, like say, like 2 over 3 divided by 1 over 2. So you want to solve this, you have to change the sign to multiplication and invert 1 over 2 to 2 over 1. So that is how you solve fractions that involve division. Now, another important point you need to remember is BODMAS. BODMAS very, very useful in solving fractions with multiple signs. So when you have multiple signs like addition, subtraction, division, multiplication, like you have brackets, you have indices. So you just need to follow BODMAS for you to get the right answer. So like if you have equations where you have brackets and multiplication, you know the bracket comes first and then before multiplication. So always remember that you follow the order as it is. Um, Very important. So bracket comes before order. Order is indices or squares or square roots. Then division and multiplication, addition and subtraction. So if you need more information of PODMAS, you can check one of my old videos. I think I've covered it at the beginning of my videos. I think something like that. So you can check that. Now let's look at another important point. So when you see something like this, it's important to know that this sign you see here is a division sign. So I put this so that you can understand what to do when you have something like this. 3 over 2 divided also by 1 over 4 is the same thing as this. So just change it to this point. So when you get from this point, you move it over to this point. So it's the same thing as 3 over 2 divided by 1 over 4. So it's important to know that. Um, Here is another important point. So if you have a complex fraction like this, so please note that since you have mixed fractions here, change it to improper fractions to make it easier. Then you change like the sign off here, change it to multiplication. And then it's important that you solve the top part first before the down part. Or you can do anyone depending on what you want. But like just take it one step at a time. So solve the top part to get to this point, and then maybe the down part to get to this point. So once you have gotten to this point, then you can bring it back to this point. So these are important points you need to note. So just take it one at a time. Another important point when solving complex fractions. So you have back a complex fraction like this, a bracket inside a bracket. So please start from the inner bracket, solve it through until you get to something like this. Once you've gotten a single fraction, then you can open that bracket and you get multiplication sign, and then you solve with the outer bracket. The point is, start with the inner bracket. Very important. Okay. Now another important point. Now this is a very complex fraction question you may see in complex exams. So you have 1 plus 2 all over 3 minus 4 all over 5 plus 6 all over 7. Now, having very serious fractions like this, please important start from the lower part, something like this. Start from the lower part. Solve it out first. You solve it out first. Once you're through with that, you bring 4 to the equation, so you have 4 over whatever you solve. Then once you've solved that, then you bring 3 minus. So just take it progressively, but point, start from the lower part first. Very important. Then you progress up until you get 1 plus whatever you have. So I'm sure you get this point. So we've just looked at some basic points you need to understand. Now we want to look at solving examples. Let me change my pen. Okay. I just hope the next one's example. So yes, we have example number 1. So this is a very complex example. Um, you're going to be working on some after the video, possibly. So let's say 1 over 10 times 2 over 3 plus 1 over 4 all over 1 over 2 divided by 3 over 5 minus 1 over 4. How would you solve this? So like I said, it just starts with the top, solve it out first, and then you go to the bottom. So let's start with the top. So looking at this, we see that there's something, we have multiplication, we have addition. Following the rule of Bodmer's, multiplication comes before addition. So we are going to multiply, and noticing here that we can cancel out here because 2 and 10 can cancel out. So if we cancel out here 2, we'll get 5 here. We'll cancel out 10, we get 5 here. So this is 1. So we have 1 times 1, we have 1 here, all over. 5 times 3, 15. Okay, then we bring our 1 plus 1 over 4. Okay, so the next point is for us to find the LCM of 15 and 4, which obviously is 60. So you know how to find LCM, so we're not going to do that, So now 60 into 15 is 4, and 4 times 1 is 4, plus 16 into 4 is 15, 15 times 1 is 15. So we have 19 over 60 when we sum it. So you notice we're through with the top part. So the top part is done. Now the lower part, so we'll just put over here. Lower part is 1 over 2 divided by 3 over 5 minus 1 over 4. Okay. Now this is division, this is subtraction. So we have to start with division first because that is what comes first in the rule of BODMAS. Now we notice that when we have to divide, we have to change the sign. So this will be inverted. You understand that? So we have 1 over 2 times 5 over 3. Okay. Now when we do this, we don't have anything to cancel out. So we have 1 times 5 will give us 5. 2 times 3, that's over 6. That's 6. So now we have to bring out this point here, minus 1 over 4. Now if you do that, you have 12. Okay, so now 12 into 6 is 2 times 5 is 10. 4 into 12 is 3 times 1, so minus 3. So we are having 7 over 12. So this here is going to be 7, sorry. Okay, 7 over 12. So we have 19 over 60 over 7 over 12. So now let's move on to another page to solve that. 19 over 60 divided, so we've changed that over to division now, over 7 over 12. Okay, so at this point we have division sign, we have to change it to multiplication sign. So we have 90 over 60. So to change this will be inverted. So we have 12 over 7 times. So that's times 12 12 over 7. At this point, there's something to cancel out because like 12 can go into 60. So we have 12 here is 1, 12 here is 5. And so we have 19 times 1, 19, 5 times 7, 35. And that is our answer. So you see the points of trying to work at a time. We started with the top, went to the bottom, and we arrived at this answer. So let's look at the next one. So we have something like this. Okay. Let me just create another page. Okay. So we have to simplify 1 over 2. So you notice it's very complex. 1 over 2 plus 1 all over 2 plus 1 all over 2 minus 1 all over 4 plus 1 over 5. So what do we do? Like we explained before, we have to start from the lower parts of the fractions. So we solve the lower part, we take it one step at a time until we climax to the top part. So we have the lower part which is 4 plus 1 over 5. And this is the same thing as 4 over 1. So we can find the LCM. Finding the LCM here, the LCM here is going to be 5. So we have 5 here. 5 into 1 is 5 times 4. That's 20. Plus 5 into 5 is 1 times 1 is 1. So this is 21 over 5. Okay. So now we can bring the 1 over. So this would lead to, we can just bring the 2 also. So we have now, since we have solved for 4 plus 1 over 5 to give us 21 over 5, we can just bring 2 minus 1 all over that 21 over 5. So it's simpler now to solve. So we're just taking it out. So 1 divided by 21 over 5, you know that that's the same thing as 1 divided by 21 over 5. And when you invert it, you have 1 over 5 over 21. And this will give you 5 over 21. Okay? So since you understand that, so we're going to have 5 over 21 there. Let me just clean this out. We don't really need it. I expect you to know that. Um, But please, if you have any question or any part I'm solving, it's important you ask. I will explain to the depth. Okay, so this is equal to 2 minus 1 divided by 21 over 5, like we just did, is 5 over 21. Okay, so now we can just find the LCM. So this is the same thing as over 1. So we have 21 here. So 21 into 1 is 21 times 2, that's 42. Minus 21 into 21 is 1 times 5, that's 5. So this is equal to 37 over 21. Okay, so you notice that we have covered this part. We have covered this part. So we are left with 1 all over what we've covered here, plus 2. So 2 plus 1 over what we've just covered. So let's go to the next page. Okay. So sorry, let me just do something. Yeah. Okay, so we had, please take note that this is what we want to solve. We've gotten these parts to be 37 over 21. So we have 2 plus 1 all over 37 over 21. So that's what we want to do now. So we're going to solve 2 plus 1 all over 37 over 21. And we know that 1 divided by 37 over 21 is the same thing as 21 over 37. So we have 2 plus 21 over 37. Okay, so now doing LCM, we have 37 here, and then we have 37 times, it's all over 1, and then 37 into 1 is 37. 37 times 2 is 74. So that is 74 plus 37 into 37 is 1 times 21. That's 21. So this is all equal to, sorry. Okay. So now if we add these up, we have 74 plus 21, that is 95, 95 over 37. So you notice, let me just go back. You notice that we have successfully, we have solved this part. Okay? Because if you see it, that's what we just did here. So taking it one step at a time is really, really interesting. So now the next part we want to look at, let me just show you, is this part 1 all over what we've just solved, which is 90 95 37 over, sorry, 95 over 37. So we want to put that now, all that is 1 all over 37, 95 over 37. So that's what we're going to do. So we're going to say half plus 1 over what we just solved. So half plus, that's 1 over 2 plus 1 all over what we just solved, which is this 95 over 37. 37. Okay. So now you know that 1 over 95 over 37 is the same thing as 37 over 95. We've done that before, so you should understand that. But if you have a question still, you can ask. So we're going to have 1 over 2 plus 37 over 95. Okay, so now LCM back again. So we have 95, oh, sorry, 95 is not the LCM, sorry. Our LCM is 190. You can check it out and see. So 190 into 2 is 95. 95 times 1 is 95. So 190 into 95 is 2. 2 times 37 is 74. So when we add that, we have 169 over 190. And that is our answer. So you notice the progression. The progression. We started from this bottom. Let me just change this pen here. So we started from this bottom here. We solved it here, and we got this answer. And we brought the 1 all over 2 minus 1 all over what we got as answer. We did it here, and we got this answer. And then we moved on to 2 plus 1 all over what we got as answer here, and we did it here. We did it here, and we got this answer. And now we have to go back to half here, plus 1 all over what we got as answer here, and that's what we did here. We did it here. And now we have finally gotten our answer. So following all the rules and steps and principles will help you to solve any fraction question you may have. So just for practice, I would like you to do this. All these examples I gave initially. So these examples I gave initially, this one, this example, this one, try to solve it on your own. Tell me what you got as answer. Following the principle I gave, this one also, try to solve it on your own. So just check it out, solve it on your own, write it down, and also this one, try to solve it on your own. And let's see what you get. Thank you very much for watching.